Hi, we are going to talk about modeling with linear and quadratic functions. One of the applications of mathematics in the real world is to create mathematical models that allow you to deal with particular situation and describe it numerically. We know formulas for some of them, like for example we know how to describe motion of a small rock that was thrown in the air at a certain velocity, and we can figure out the height of that at any point in time. But often with many situations in real life you have to deal with some data that you collect over time. So what we have here is an example. Melanie Shop has been tracking sales of a popular decorative shelf. They started making it in 2007. This is the data that they've collected so far. So we have years here and thousands of units sold. So we gotta find all these different things here. I suggest that you stop here because I'd like for us to move on. So if you want to know what the questions are, you may want to pause this video and take a look at what we're trying to do. But essentially what we're going to try to do is we want to try to create a linear model for the data and also a quadratic model for the data, and we're going to compare them and see how they're the same, how they're different, and how they're accurate or not accurate. I'm going to use a TI-84 calculator that has capabilities of creating regression models. So let's move on and go ahead and do it. So this is the scatter plot with the data that we have. I can zoom in just to show you. Here's what we have. And this is the data collected so far. Typically there are questions that a business may be interested in knowing, like if you have specific data over a period of time, how can you predict what's going to happen in the future using these data? So it's a very much real life situation. The first question here is to find S of 11 minus S of 1. So S of 11 is the number of units sold in 2018. S of 1 is going to be the number of units sold in 2008, and we're going to divide it by 10 minus 1. 11 minus 1, which is 10. So it's 5 over 10. So it's about, it's actually half, right? 5 over 10 is 1 half, or you can write as 0.5. Correct? So what we're going to do next is we're going to attempt to fit a best fit line to this set of data that we have. So for that we can use our calculator that will allow us to figure it out. So what we're going to do is, alright, here's my calculator. So I already entered the data. If I go here, you will see that I entered the numbers. So these are the numbers that represent years after 2007. These are the numbers that we're using for thousands of units sold. So if I exit this and I go ahead and press that button again and go to calculator, your calculator may have different buttons that you have to press, but what we're trying to go for is linear regression. So right here, option number 4. So I'm going to select that, and I'm going to select my lists. So it's going to be list 1 and list 2, and then I'm also going to send it directly to my y variables, so that it will automatically store the function in the calculator's memory once it figures it out. So press enter, it will calculate the function for me. I set my calculator so it gives me numbers accurate to 2 decimal places, just so we don't have to write very long numbers. And if I go to graph now, this is what we're going to see. This is our data points, and this is the line going through that. So let's move on to our next slide, which is going to have that same data. So the equation that we got here, S of t, is going to be 0.51 t plus 0.91, which is that line. So now we see them graphed together, as I already showed you on the calculator. Now we're going to try to answer questions. So our linear model again is 0.51 S of t equals 0.51 t plus 0.81. So using this model, we want to predict the number of shells that we're going to sell in 2021. So 2021 is going to be how many years after 2007? which is when we started this. It's going to be 14 years later, right? 14 years later, or 14 years since 2007. So what I'm going to do is I'm going to calculate as of 14. Yeah, do not put 2007, that would be grossly incorrect. So instead of us playing with these numbers, we are going to go to the graph. And what we're going to do here is we're going to press calc, and we're going to calculate the value, and we're just going to type in 14, and we're going to get that they are going to sell a little over 8,000 units. So we're going to approximate about 8,000 units. Okay. So if we use the model, when can we predict that they're going to hit the 11,000 unit mark? For whatever reason, they're interested in an 11,000 unit mark. So we can do it a couple of different ways. One way we can do it, we can look at the graph and see if we can pinpoint 11. So 11,000 would be here. So roughly it's going to happen sometime between year 19 and 20. So after probably 20 years, after 19 years at some point, it's going to happen. Another way we can do that is make it more accurate, which is setting it up into an equation. So we want to set the quantity, which is S, to 11, 0.51 t plus 0.91, and solve that. So 0.51 t is going to be 10.09, and divide both sides by 0.51. So 10, what do we have here? 10.09 divided by 0.51, and we get about 19. So t is going to be approximately 19.78 years, as I said, so we're going to round it about 20 years. Okay. So that's as far as the linear model. Okay. So let's go ahead and try to do it with the quadratic model. So now what we're going to do is I'm going to go here and I'm going to delete this, and I'm going to repeat this process, but now I'm going to do the quadratic model. So we already had the data. This is the curve that fits this data, but I'm going to repeat that. So I'm going to press Stat, go to Calc mode. I'm going to find Quadratic Regression, which is option 5 here. Oops, I'm sorry. Well, it already knows automatically what it needs to do, but I meant to do something a little different. I want this to store my equation in memory, so I'm gonna press this again, but I'm going to do L1, comma L2, comma vars, y-vars function, and hit that, and now it's going to give me this equation. So my equation is going to be 0.03x squared plus 0.9, well, it's going to be t, except instead of x. So 0.3 t squared plus 0.19 t plus 1.57. This is the quadratic equation. 0.03 t squared plus 0.19 t plus 1.57. So this is what it looks like. And I can also show you on the calculator. It's going to be the same thing. Okay. So this is a different model. Obviously it grows faster. You can see it. It doesn't grow linearly. Does it follow the data more accurately? Probably. All right, let's take a look. So the quadratic model here is 0.03 t plus s of t. 0.03 t squared plus 0.19 t plus 1.57. So if I want to find the number of shells that we predict to sell in 2021, I want to use 14 years again, right? So it's going to be S of 14. Again, instead of doing math by hand, I'll let the calculator do it. So on my calculator, we're going to go to calculator mode, select option number 1 for value, type in 14 years, and we're going to get a little over 10,000, 10.11 thousand. So it's going to be approximately 10,000. When do we predict for the shelves to be sold in excess of 11,000? Well, since we already know after 14 years it's 10, it's probably going to be close. Now we have one option of solving a quadratic equation, which I'm not going to do that. So what we can do is just roughly make an estimate. If I go ahead and hit the calc and go to option 1 and type in the, no, I'm sorry, hold on, I was going to do 15. After 15 years, you're going to go past 11,000. So we know it's going to be after 15 years. It is going to grow faster. Okay, so what we'd like to do now is compare the models and see what we can come up with. So we're trying to compare results between parts, the results in C and F. So in C, we ended up in 14 years. So 14 years, right? So according to model C, we were at 8,000 units. According to model F, we were at 10,000 units. What about the results between parts D and G? So in part D, it would take us 20 years, according to model D, 20 years to get to 11,000, to go past 11,000 units. With model G, with quadratic model, it's going to take us about 15 years. Okay, so this is what we know so far. It is probably expected that the quadratic model is going to grow faster, and as a result you are going to get whatever your goal is as far as quantity faster, and it's going to take you less time to attain a particular value. But how accurate is going to be the quadratic model? Remember, quadratic model is going to continue to grow, so is it going to be possible to sustain that type of growth the whole time? Let me show you this graph again. Let me show you this graph comparing against the linear function. So this is the linear function. Well, this is when it takes us 20 years to get to 11,000. This is the quadratic function. So quadratic function seems to fit the data much better. It grows faster, but the question for that type of model is going to be, because this is supposed to gain more and more each time. And I don't know if it's going to be sustainable, but that's a question for another discussion that is subject to interpretation. So, but this gives you an idea how two models compare and what you can do with that, okay? So I hope this was helpful.